looking at all of your lab stuff. Believe it or not, I could figure out all of your data, your mass of water, your volume of water, and your density just by looking at your graph. You're going to figure out how that works today. So, looking at your graph, your numbers, remember how I kept freaking out and I could walk by and we would tell you, oh, your numbers are off? And we would make you redo things? There's no way you were going to get the numbers spot on to what it needs to be. So what I've done is I have made a graph of what the data results should have been. So you can kind of compare your results to what the results in a perfect world would have turned out to be. So my data table would have been 50, 50, 100, 100, 150, and 150. Were you guys close? Yeah, a lot of you were really close. And some of you were even when, I noticed with the 50 milliliters the most, you guys were the closest. Like you were only tenths off from your answer that you should have gotten. So now what I've done, I put together a lovely chart for you. Isn't it so perfect?
Yes.
Annika's like, no, what are you talking about? Annika is not afraid to hurt my feelings. Okay, Annika, what's wrong with my graph?
You don't have a label.
I don't have any labels. Now, the importance here, any scientist should be able to pick up your graph and know exactly what you did in your experiment. It should be that detailed with labels and titles. Pretend that you're just looking at my graph and you did not know what we did in our experiment. You were sick the past week. Would you have any clue at all what I was talking about?
Nope.
No. So let's fix my graph. Well, we're fixing my graph. I want you to be double checking your graph. You have everything on your graph that you're supposed to have. So, Annika, you told me labels. So what am I going to be labeling? Can you tell me one label I'm missing?
You need the mass of the water.
And what axis is my mass of the water going on?
Your Y.
Very good. Remember how Y is a long letter? So this is my Y axis. So mass of water. Okay. What's another label that I'm missing? Caitlin?
You're missing the X.
Very good.
Axis, and it's volume of the water.
Very good. I'm missing another label. Mia?
There needs to be like milliliters.
Very good. These are the tiny little things that everybody always leaves off. And I still see them on some of your graphs that you don't have. What am I measuring my volume in? Because for all I know, I could be measuring it in liters. I could have been filling up it would have been 25 top bottles with water. No, not even, 25. Does that make sense?
Mm-hmm.
No. Or 50, what if I said 50 liters? Am I filling up 25 2-liter pop bottles? What were you filling it up to? You were using graduated cylinders. Those are tiny. What unit should I have? Peyton? Milliliters. So instead of writing milliliters after every single number, what I'm going to do is just write it like that. And what units were we using for mass? Don't tell me. Pounds. Thank you, Tyler, for saying no. And Elisa was like, that is ridiculous. What should it be? What should it be, Elisa? Grams. Thank you. Pounds should never even enter your mind because we're not dealing with the weirdo United States measurements anymore. We are completely scientists with the metric. Good. Now, what else am I missing? Anything else? Izzy?
The title.
I have it. Chart title.
That's a perfect title.
Is it? Is it true? It's perfect? I think not. Emma, what are you thinking?
I can't say.
I know, that's a weird word. Specific. specific. So how can I make this more specific? What do you suggest?
Mass versus volume of water.
Do you know what I like about that? She's telling me that I'm dealing with mass and volume. I'm looking at that relationship. Some people just wouldn't say though, mass versus volume. I could be talking about the mass versus volume of my brain, or my eyeballs, or my feet. You don't know what that is. So we need to make sure that it's very, very specific. We're looking at the mass versus the volume of water. Anything else that I need to add? Caitlin?
For the point, like, we put like in parentheses, yeah, like coordinates.
Oh, okay. So you labeled your points. Now, I did not make that a requirement, but I think it is a very good idea because how many of you had decimal points? And if you go back to that graph and I don't let you look at your data table, could you tell me exactly what those numbers are? No, it's really hard to estimate decimal points because a lot of us had to use, in order for our scale to fit on our graph, our intervals had to go up by like tens or fives. So it was really difficult for us to estimate what those decimal points would be. So I think that was a very good idea for some of you. So let's do that right now. If you don't have them labeled, let's label them. So how you label them, you put your coordinate pair. So coordinate pairs, you always have your x first and then your y. So my x was 50 and my y was 50.
So you need to know the coordinates. So what was this first one?
Yeah.
So Katie is first. Which part's left? And it was like sweet something, right? So we're gonna go back here. And I'm gonna label it. See how that works? Okay, so that has to be like in the whole document, she's gonna go the express and then this is that way, right? So do your other just make sense. Okay. That you come over here, that was your nice. So now you're gonna go 100 and with your 95, so three.
I'm good.
That's okay, so now we're gonna go to 100 and then you're gonna go to 95.3. And then make sure you reach the mark.
Okay, so as some of you are finishing up, the rest of you look up here. Does my graph look complete?
Yeah.
Look how smart you look, all that stuff on there. Your graph looks beautiful, okay? Now, after you made your graph, I asked you to look. Did you see anything interesting between your mass and your volume? So now here's where we're pulling in some of that relationship talk. And I saw a lot of you said, oh, ours are all really close together. Like really, really close together. Like you had 0.98 and 0.96 and 0.94 maybe. Or some of you had like 0.98, 0.96, 0.98. Or you had, yeah, those are the ones I think popped up the most. When we were, oh no, I'm skipping ahead, sorry. X that out. Looking at your mass and your volume, you had 50 and like 48.4, or 199. So what did you notice? 199, 48 and 50, or look at the answers that you should have gotten. 50 and 50, 100 and 100, 150 and 150. There should be something glaring at you in the face right now. Especially with my data points. What is so crazy about the numbers that I got for my mass and my volume? Peyton?
We're really close.
They're really close. Your guys' should have been really close. Mine, exactly the same. Exactly the same. So if we were in a perfect world, we would have found that our points were exactly the same. Mass and volume. Your mass and volume are exactly the same. Or for you guys, they were really, really close. Good? Now that we looked at the relationship between mass and volume, now I said, okay, let's pull the density. And I'm going to go over this one more time because looking at your homework, some of you are still not following the directions on how to write your formula for density. And I'm not sure why. Because on the video, it showed you very clearly what each step was supposed to be. And it's really no different than what the steps were for the formula work for volume. If you choose not to do it now, you're setting yourself up for bad habits because all of your science classes that you take in high school and your college chem and college physics, they will make you show your formula work. So you're just silly if you choose not to do it. That or you're lazy. And I don't want somebody to call me lazy. Do you want to be classified as a lazy person?
No,
No.
no one ever wants to.
Right.
Because
So-
if you're lazy, you would be like this.
Yeah.
This is someone who's not lazy. Someone who won the like
The Olympics?
yeah.
Yeah.
Good.
Good.
It's a whole big
Okay. So, one more time. You better be looking at your paper. Your paper better match what mine looks like. Now, you're not going to have the same numbers, obviously. But you should have your first step. What is the formula for density? Jasmine? Mass divided by volume. And I told you, you could either write out the whole word or you could just put the letters. So you had some choice there. But the first one is you're always telling me what your formula is. Then your second line, you're going to substitute your numbers. So for my mass, I had 50. And for my volume, I had 50. Density is where you want to keep track of your units. Because did we see the weirdo unit that we ended up with? Okay, so I want to make sure that I put, for mass, I used grams, and for volume, I used milliliters. This right here is going to help me in my next step. Then my third step, what's 50 divided by 50? Everybody? Thank you, I did not hear a 0. Any number divided by itself is always 1. And then we have that really weird unit. We have 2 units put together. Grams per milliliter. It's just like you can think of mile per hour. Same thing here, except we're saying grams, and whenever you come across this little division sign, you say the word per. Milliliter. So everybody say that right now. I want you to look at your answer, and I want you to read your units correctly out loud. And if you have the wrong units, you best be fixing your units right now. Okay. I'm going to give you 5 seconds if you can fix your units. On the count of 3, everybody say their answer with the correct units. 1, 2, 3. Now, just tell me the units. Everybody on the count of 3, just your units. 1, 2, 3. One more time. 1, 2, 3. One more time, because I'm not hearing everybody. 1, 2, 3. Grams per milliliter. Very good. You would be amazed at how many people get confused by this and can't read it correctly. And then when you're out in the world and you have to read this and you say grams divided by milliliters. They're going to look at you and be like, who was your 6th grade science teacher? And I will hide my face in shame. So, do not forget this. This means per, okay? Now, some people ask me, you can remember it. You can write this differently, and it helps them to remember their units. Some people like to write it like this. 50 grams divided by 50 milliliters, because it helps them to remember to take this and that, and you just stick it together. So if that helps you to remember to write your units the proper way, you can do it that way too. And then, for my other one, what's 100 divided by 100? Beautiful. Oh, thank you for whoever said grams per milliliter. And my last one was 150. What's 150 divided by 150?
1
Good. I heard more people saying the units. 1 gram per milliliter. What do you notice? Gage?
All the densities are the same.
Does that not freak anybody else out? I just think that's weird. That is weird. All of my answers are 1. Now look at your densities. You should have seen, and a lot of you came up with that this is the relationship. Now all of your densities, were they close to being the same number? And how many, if you round it, would it round to 1?
No.
Raise your hand if your answers, all of your densities would have rounded to 1. If you had 0.9 anything, your answer would have rounded to 1. Okay? So, what we're seeing is the density of water, no matter how little or how much we have, will always be 1. So if I have a huge swimming pool filled with water, that water, the density will always be 1. If I calculated the density of an entire swimming pool of water, it would be 1. Or if I calculated the density of the water in an eyedropper, it would be 1. And we'll get to that next week. Ocean's going to be a little bit different. Ocean water, think about what's ocean water. What's the difference between water that we drink and ocean? Salt. Salt water is different. Just regular old water. That's what we're looking at right now.
It depends on how salty it is. Because some people are salty make salt crystals.
Okay. Now, this is what I want you to make sure that you're taking away though. No matter how much or how little of this substance we have, the density stays the same. So even though it gets bigger, that doesn't mean the density gets bigger. People always forget that. What will be the density of all of the fresh water on Earth? 1 grams per milliliter. Okay? And here is where we start the journey to blowing your mind with math. I want you to prepare yourself because you all know how much I hate math, right? I talk about it all the time.
I love math.
I was not good at math in school. I only like math due to the fact that I love science and math just comes along with it. So I plug my way through the math. It has never been easy for me. And to be honest, if you would have showed me this in 6th grade, I would have been like, what are you talking about? Okay, so be prepared. This is going to be a stretch. You are moving into 7th grade math right now. Yes, okay? Looking at this right here, I told you at the beginning of the class, I could look at your graph and figure out the mass, your volumes, and the density of your substances. What we're going to look at here, do you see any connection or any pieces of information from your graph that I could use to help me figure out the density? Is there any information on your graph that I could use to figure out the density? If I didn't have your data tables and I needed to figure out your density, is there any information I could take? Gabby?
Well, on the video it said that math time.
Close that time. There you go.
Volume.
Okay, so on the video we said that the formula for density is mass divided by volume. These are variables. You talked about variables in math class, right? What's a variable in math class? Elisa, do you have it? Have more confidence in yourself. What is it?
I said, it's like a letter or something that stands for.
Right, we can put the numbers in for the variables. Would we be able to put 2 different variables in there from the graph? Do you see any other letters on here that we might be able to substitute into that formula and it would still mean the same thing? Caitlin?
X and
X and Y. Now the trick is though, which one goes with which? Does the X go on the top or does the Y go on the top?
Y.
The Y. Why?
Because it goes like
What's
it's
on the
the
wall?
math.
There you go. The Y is where our mass is. So then our X is going to go on the bottom. Now, if I look at one of my coordinate pairs, let's just choose this one since I have it labeled. I could put in 50 is one of my X values and 50 is one of my Y values, which equals 1. Wait, did I see the number 1 anywhere else? That's the density. So I could use your graph to get the density. There's another way though that we can actually show the density on your graph. Drew, did you have an idea?
See that the title says water, and this one goes like this is one.
That's true. You have that fact memorized, but there's going to be some substances that we don't know what the density is. So what I've heard throughout the entire day, some people said that we should just plot a point at 1, a different color and label it B. But that really wouldn't work because we're talking about mass and volume here. Other people thought that we should add another y-axis over here. But would that work? Because then what would we know how to use what numbers for what? That would just be crazy. Some people said that we needed to add another line of data. But they didn't really know where to get that from. And they were the closest. We are going to add a line onto our graph. It's called the best fit line. All a best fit line is it's a line that is as close to all of your points as possible. So you're going to try to get a straight line to go through all of your points. So some of you have points that look like this, kind of here, here, and then some of you might have one like kind of up here. Some people might. In last period there was more. Your guys' data was pretty actually spot on. But what we're not going to do, we're not just connecting the dots. That would be making a line graph. We're not doing this. What we're doing is we're trying to make a line that'll be closest to all of these points. So what I would probably do, and you need to have a straight edge to do this the best, I would take a line probably up through this point and split in between those two. Do you see how I try to get all of my points as close to the line as possible? So that's your goal right now. You're going to take a straight edge and you're going to try to make a line go through as many of your points as possible. If you don't have you have a ruler in your little agenda book, or even just your book itself is a straight edge. Okay, so what you're going to do, you're going to take this line here, and you're going to try to get it so that it goes like close to all of those. Here's your best fit line. You're done. Yep, just see how close your data points were, that they almost hit the line exactly.
I hate all Shake
You
your
can draw
body
like
much.
past your cool. And then go down below that one too. To that point, draw your good. So just
I think it touched my things.
That's how bad it was.
I know.
I was gonna catch you.
Okay. Good. What I like that I'm seeing, I'm not seeing people do this. We are not connecting the dots. We're just making one straight line. One straight line. Now, does it kind of look, I'm feeling very artsy today. I can kind of envision that I'm making like a drawing of something. Does anybody else see like a drawing of something?
Nope. Nope. Not at all.
What? Oh, wait, say that louder, Jacob.
The side of the mountain.
Does anybody else see the side of the mountain?
No.
See, look, right here. Here's your side of your mountain. Okay? You have to use your imagination. You see the side of the mountain. How many of you have ever heard of like skiing or snowboarding?
I know this. There's a video.
Okay.
I almost killed myself on one. Ready, go skiing.
Now,
I almost killed myself on one.
when you ski down the side of a mountain or snowboard down the side of the mountain, what do they call that? You're going down the what? Right?
The summit?
Not
The
summit. The slope. The slope. And what's really interesting about this, slope has a different meaning in math. We're actually going to talk about the slope of the line. There's a formula to figure out the slope of the line. Do you know it, Drew?
It's like y equals m.
No,
Something like that.
no, not quite. It's really actually funny. There's no variables in it. Wait till you see this. It's called rise over run.
Never mind.
Sometimes I spell that rise with a Y. I'm not very good at spelling, but it helps me with this.
Now, what we have to do is we have to figure out what numbers could we put into this formula. So I like to think too, Mrs. Miller, that was, Miss Spelling is really helping you out there, where we might be able to get some numbers from for the formula. Or you could think, if we're rising, where might we get some numbers on the graph? What's rising on the graph? Or what's running on the graph? We're all dealing with the rise and the run. Is there anything on our graph that might be rising and running? Gage?
Well, the rise would be the y-axis, and the run would be the x-axis.
See how the y-axis is rising on your graph, and your x-axis is running along your graph? See how you run horizontally? And then if you rise vertically, just the way this is. So now, if we look at our coordinate pairs, x and y, so I can rewrite this as y and x. Do you see why Mrs. Miller misspells it as rise?
Yep.
Yeah, because it shows you about the y there. Now, if we look at our coordinate pair, what is my y in my coordinate pair? 50. What's my x? What's 50 divided by 50? Get out of town. Oh, why should we put grams per milliliters?
Because it's a
That is! It's the density. Look at that there, and look at this here. Mind blown. There's your relationship right there. Mass, volume, and density all go together. Your mind is. I think that's amazing. That something you didn't even know existed is putting all of this together, all in math lingo. Caitlin?
And also for the rise, it kind of, for the Y, it looks like it's kind of slanty, like the.
Oh yeah, yep. There you go. So this is what you have to look forward to in 7th grade math.
No.
The good news is you have a whole half of a year, right, before you get to 7th grade.
No.
Yes, you have half of a year.
We don't.
Oh well, you're on your own. You're ready for 7th grade math, okay? Now, many of you are looking at me like, whoa, what does this even mean? So what we're going to do, we're going to put it into the English language. Take it out of the math language and put it into the English language. But I felt like I needed to show you this because isn't that so cool? And look at everything that you did. I'm sorry, this looks like a board from Sheldon on Big Bang Theory.
Yes.
Yeah, look at all the formulas that he uses and all the graphing. You're as smart as Sheldon.
Yeah.
Okay? Now,
We were watching Big Bang Theory the other night, and he had this board out, and
And they'll
he's
be
trying
good
to
for
figure
now.
out something about electrons, something about the flow.
was that where he jumps into the balls of pit, the pit of
Yes.
that's my favorite one.
And he's like hilarious.
Yeah, I'm sorry, I love
And
Big
he's
Bang.
like machine gun.
Yeah. I love Big Bang. I have all 4 seasons on DVD. I got
Oh,
all.
that's not good.
Not all 4, but half of them. There's 8 seasons. So okay.
The Big Bang Theory was a reality TV show.
Not reality.
Yeah, it's like a comedy. Okay, so what we're gonna do, we're gonna take this information here, and we are going to put it into English forms. So you've been sitting for a while. You can stand up. While you're standing up and stretching, I want you to get out your Google Drive on your computer.
Never been in a ball pit before?
I almost killed myself in a ball
That's how they explain the slope.
I almost killed myself in a
Do
ball
you know what
pit.
you're talking about? There actually is, like, it's like y equals x plus something. Like, yeah, and so what it is, in front of the x is actually your slope. You'll learn that when you get into like calculus. It's like calculus type stuff. Yeah, so you'll see that. Okay, are we nice and stretched? No. You have 5 more seconds. Get all the stretching in that you need.
I don't need stretch. I'd rather have it work in my neck than
Okay, here we
a
go.
whole lot of time.
5, 4, 3, 2. So what I want you to have pulled up, if you don't have it pulled up yet already, it says mass, volume, density, relationship, graphic organizer. It's a really long name.
No, but it's math first. Math? But he's a math volume density relationship graphic order.
Yep.
That's it.
Tree, did you find it? I can't see it.
I'm on
Okay. So what I decided I'm going to start doing, just to kind of help you study, I'm going to start putting the objective that I feel like this hits the most, so that when you go to study for your quiz or your test, you're like, well, what can I study for that objective? When you go back through your materials, you see, oh, this objective goes with this. Now, that doesn't mean that these other ones don't fit in here, but I feel like this is probably the most important objective that I'm hitting with it, okay? So we're explaining the main relationship between mass, volume, and density. That's our first part. Then down here, this is going to help you support your explanation with examples of different relationships between mass and volume. and how changing your mass and volume can actually affect your density of a substance. And then I also have some other important notes that we're going to add for each investigation that we look at. You've been sitting a really long time. I showed you the crazy math language of how mass, volume, and density are related. We're going to act it out right now. And it's going to help us to come up with the actual English explanation. So I need you guys to push this desk up. I need you guys to push your desk over just a little bit. And I need everybody to stand up. Oh, sorry, Lisa. Can you guys push your desk? I forgot to tell you. Okay. Actually, you guys are a rather large class. Let's move your desk over a little bit more. Just a little bit more. Yep, you guys are large. Don't squash Lisa. There we go. Okay. You all are going to become what? Models. Now listen to what type of model you're going to be. You're going to be a model of the smallest unit of matter. Can you raise your hand and tell me what is the smallest unit of matter? Emma? An atom. Or you can be a model of 2 or more atoms bonded together. If you choose to be 2 or more atoms bonded together, what are you a model of? Tyler? A molecule. Very good. Now, you're not actually going to be bonded together. We're just going to be like this, and you're going to pretend that you have an atom here and an atom here. We're not going to bond to each other in this one, okay? Or if you're an atom, you're just going to be straight down by your side. So choose right now, are you modeling a molecule or an atom? Your molecule choice is here. Your atom choice is here. If we cannot be mature enough to handle standing up and acting things out, I will ask you to sit down individually. I'm not going to punish the whole group for the mistakes of you, okay? So, you are now modeling either atoms or molecules. What could we classify both atoms and molecules as? They are what? Grant? Matter. Very good. What do we use? Well, not tool, I shouldn't say that. How do we measure matter? What measurement do we use for matter? And this, my little people, this is why we need to study tonight with Quizlet. This will be a question on your test. What measurement do we use when we are measuring the amount of matter? Emma?
Centimeters squared.
That's what we use when we're measuring, that's the unit we use for area. Mass. Mass is the measurement of matter. Okay. All of you matter. You are going to come into this amount of space. Remember, we're being mature. So you have like the edges of the desk. That's as far as you can go. That's your space you're allowed to be in. So Tucker, are you inside the desks? Need to step in. Oh, you guys are a little awkward group of matter. Okay. Okay, so I gave you a certain amount of space that you are allowed to be in. What measurement do we use when we're measuring the amount of space? Gabby? Volume. Very good. Now, all of you little particles, because there's atoms and molecules in here, right? Yeah. Okay, so I'm just going to group you as particles right now. I want you to make yourselves become very dense. Do you know how you would do that? Oh, Gage has an idea. What's Gage doing? There we go. Okay, not that dense, not that, nope, not that dense. We're being mature amount of dense right now. Okay. What did you guys do to make yourselves more dense? Okay,
Closer together.
the particles got closer together. Are you still within your amount of space? Are you still matter? So, density then is the amount of matter in a certain space. And if we want to become more dense, the particles of the matter get closer together. And so, why don't you right now, you have to stay within your given amount of value, now make yourself less dense again. Nope, you still have to be within. There you go. Good, so you guys actually spread out. Now I'm going to say, I'm not going to give you a certain amount of space, you're going to become way less dense and spread out to your seats.
Still think we go a little bit back. Okay, so,
So, when we're talking about density and how it's all related, without mass and volume, could we even calculate density? No. Doesn't make a period sign. Okay. Does anybody have a charger?
I got one.
Would Jasmine be able to borrow your charger?
Yeah, sure.
Thank you, Train. Why don't you and Drew trade places? Actually, our bell's gonna be ringing. Don't even worry about it. Okay, so looking here, density. Train, never mind. It's okay. I didn't realize our time
I was
so
putting
short.
it back.
Oh, okay.
I was going to
Density.
say she could just wait for it to die until the period ends.
Density is what then? You guys, I was actually able to measure your density by how close or far away you were, because I could look at how much matter is in a certain space. Yes? No? How much matter, how many of you particles were there in a certain space? And when we look at how much matter is in a certain space, what are we measuring? Density. Okay, so Jen, why don't you just come and drink from base tomorrow, and I'll get you caught up in your typing. So in our main relationship, this is what we're going to type. Density measures the amount of mass, or we can think of it as matter, in a certain volume or space. Does this look familiar to anyone? Why is it looking so familiar, girls? It's the density definition. Oh my goodness. You knew the relationship the entire time, and you didn't even know it. Remember last week when we broke the definition apart to make it make more sense? There you go. There you go. So you see how it's starting to come together. Once you have this typed, we need to move our desks back and put our chairs up in the front and a chair up in the back. Oh, there's only a few chairs. And then you're free to go.